Okay, so I think, yeah, okay, so like we're gonna try to stream for like 10 minutes. So, what we have here is a visualization. So we're trying to understand how like neural nets like to generalize. And so what we've done, I mean, it's literally one person, like I did it. So like what I did was okay. So we have like a neural net. Okay, let me show you the codes. This is in beautiful JavaScript because JavaScript is beautiful. So this is okay. So like this is what we're doing. We're we're making this like little I guess like two, or I guess like three layers, depending on how you count your layers, and 10H. We're using like 10H activation. So anyways, this is the neural net, right? And so we're doing this 50 times, like we're creating, so it's like each of these images corresponds to a different neural net. And we're then training the neural net to fit a training set. So that's what the, so like the green dots are inputs. I guess I should explain that like the cells like in each individual grid correspond to inputs. So we're interpreting the neural net as a Boolean function. So it's so in this case an 8-dimensional Boolean function. So we have like 2 power 8, which was 2, 4, 8, 16, 32, 64, 256. You should probably know that actually. But anyway, like it's 256. So this is like so these are like 16 by 16. I should probably like draw like borders for the cells. But anyway, so each cell like corresponds to an input, and like we're arranging the inputs kind of arbitrarily, like just in order, like numerical order. Yeah. Okay, so then we have a training set, and so we're saying like the green inputs are inputs that are supposed to be gray, or like I think 1, like the output of the neural net is supposed to be a 1. And then on the red input, so like this green input is misclassified, like in this particular instance. So as you can see, like in this particular instance, the neural net gets everything correct except for this one green guy. But like over here, it gets all of them correct. Yeah, and so the reds are, like -1. And so we're taking the exact same training set, and we're just like basically the exact same neural net. And we're reinitializing the weights multiple times. And then we're visualizing the like full function that the neural net selects, because like in the training, like it only sees the inputs in the training set, so like it doesn't see like any other input. And so like it's literally like guessing, or like just using its like structural like bias for like what unobserved inputs should be. And so I guess it's like that structural kind of bias we're trying to like observe. We can see that it's I mean like pretty regular. So yeah, I mean I guess like the concept of like trying to characterize the well, I guess we're just trying to do it like visually, right? So you can see that it's like in this case it tends to prefer like long columns. So let's like refresh, like run So it's going to randomly select a training set, which is just like 10 random points that it randomly assigns positive or negative. And then we're going to retrain the neural net on the new training set. So like, let's see what that looks like. Right. It's kind of, I mean, it's kind of ridiculous, frankly. I mean, like, so like this, like in this instance, the training like is 100% correct. Like every training, every training input is correctly classified by the neural net. But like it's completely absurd. It's like, okay, so I just thought of like a good idea. I don't know how to implement it. That like it would be basically like we take a training set and then like like just remove one of the points. Because like so for instance, like if we remove this point from the training set, like would the neural net still have like this weird arm coming down? It's like it possibly would, right? I mean, like you have a weird structure here for no reason. Here, the neural net likes to do upside down Fs. Like why? Here's a misclassification. I don't know, like I think I found this test set difficult. Like there's a lot of misclassifications. Yeah, there's like way too many misclassifications. Okay, so one thing we'll do is turn down the number of points in the training set. So this is like hideous. It's like hideous code for producing the training set. And so anyway, like it's saying we have 10 points. So let's say we have like 5 points. And I mean, like if you get 5 points, you're gonna have like more variability in the like in the functions that the neural net is selecting. But I mean, I think one thing we can be pretty confident on is that the neural net likes repeating structures. Which seems to have like an intuitive like because like functions that have these repeating structures mean that they like in some sense are simple or whatever. So like I guess like they have low complexity. Depending on like your favorite metric of complexity, like you have like I think like decision tree complexity, like circuit size. But anyway, like clearly it's the neural net like is preferring visually functions that are repetitious. Let's say like does it correctly classify on every instance? I think it does. Right, like I mean it literally makes no sense, right? I mean it's just like all the neural net is saying, all you're telling the neural net is like these points, and then the neural net is like hallucinating, like, oh yeah, there should be like columns. There should be like these weird columns going everywhere. I think like if I guess like if you're thinking of it as like analogy with like an image classifier, then I guess like the green points would be like images that, like maybe you're doing like a face detector. So like the green points would be like faces, and then everything that's gray would be like what the neural net is generalizing to as a face. So I mean, like, it's completely absurd. Like, it's just like, okay, there's these 3 points, and then the neural net is like, yeah, this entire area, this is all faces. This is faces, this is faces. I guess we could, here's the thing we can do. We can, what if we make the neural net, like, bigger? I guess deeper. Yes. Because we're deep learning. So you gotta make it deep. Okay, so that's, although we also have a different training set, so we can't, so it's like in this case, the training set is like 4 positives, 1 negative. So like the vast majority of the inputs are being assigned positives. But again, like, it's weird. Like, it's still weird, right? Because like it's like there's this 1 negative point here, and then the neural net is like, yeah, like literally all of these are all negative. This is negative. It's like, why? But it's like somehow if you scale this up to, like image dimensions, and you add like more layers and you make them like convolutional or something, like they seem to generalize correctly. So that's like weird. Okay, let's do the same thing with a different training set. And then like I have to go because like I gotta, it keeps giving me like a 4-1. Now like this one, it kind of created almost twice. Like this one is like highly regular. It's so weird, like it has to account for this 1 red point. And so it keeps like hallucinating like all these like ridiculous structures. I like this one. Like this one, it didn't correctly classify the red point, but it put a point up here that's... This one, it misclassified a green point. Let me go back and add more training points. We'll say like 8, right? Oh yeah, I don't want to confuse it with this 8. That's the dimension of the input. This is the number of training. Okay, so now it's like, it's not correctly... Well, it kind of is. Okay, so it's not fully correctly... okay, let's give it more epochs. Epics. It needs more epics. Okay, bombs away, and then... Okay, so yeah, I got that correct. Got that correct. Got that correct. It's getting them all correct. Right, it's just like, why would this, like, correspond to, like, correct generalization when it comes to, like, all the modern day deep learning stuff, right? Doesn't make sense. It'd be cool if my computer could run this like quicker. No, quickly. No. More quickly. Okay, so anyway, thanks for watching.